Good afternoon, everyone. I'm Patrick, currently a bachelor student from CHK, and today I'll talk about our project From Craft to Community, which is about a digital framework that we developed over the past year on participatory upcycling. So in Hong Kong, 1 million tons of wood and other materials are wasted every year, but our local upcycling capacity still remains low. Our project explores ecological community building through enhancing public participation in architectural production. In the cooperative process, metaphors and automation technologies are used to interface design, communication, and fabrication. The study hopes to produce generalizable outcomes for densely populated neighborhoods worldwide. The main challenge for us is to standardize our approach while enabling participatory flexibility so that citizens can participate in the production process and together we can test different design ideas. We also aim to keep everything contained within a community scale. In other words, we're seeking alternatives to industrial machines, which bring us to the tech aspect. At the start, we want to experiment with upcycling with an approachable material for digital fabrication. And as we begin to look around, we discovered that wood waste is in Hong Kong is just lying around everywhere. So I'm gonna show you a few photos of how much waste wood we found in our neighborhood. So this is Exhibit A. These are waste materials from our studio. It has a lot of like gun nails, and we had a hard time trying to remove them very carefully. And then this is Exhibit B. This is from a theater performance. Most shows in Hong Kong nowadays throw away a lot of the props when the performance ends because they need to return the venue as soon as possible. We had to collect this stage at midnight when they throw the wood out. And then this one, Exhibit C. This was sourced from public housing with around 9,000 residents, and there's always home renovation happening. However, if the wood is left outside or too long, the sun and rain will ruin it. So we'll have to salvage it immediately when we receive a call. This project came from the motivation of what I can do for my community as a digital designer. The key challenge for us is the material variability in urban waste. For example, the material come in different shapes, thickness, strengths, and qualities. And there's a lack of community agency in upcycling. For example, there are multiple instances that we have to stop immediately for safety concerns in the workshop. And there are also limited craftsmanship and machinery skills at the start. And so we set our research question specifically for how can digital fabrication methods enable participatory upcycling in dense urban context. We attempt to develop a framework through action research as the methodology. We spent a lot of time understanding and preparing this material using design for disassembly logics. We went to public housing and performance venues to repurpose waste materials into community furnitures. Digital fabrication method enabled resident participation in the upcycling process, including using CNC milling to mitigate risk through community woodwork, using design for disassembly to prolong material life cycle. While we also innovate a heat shrink plastic joinery system with waste plastic bottle that has a nail-free design, enabling future reuse of wood panels. It is important to note that the plastic waste bottle are commonly found, a flexible material, enhancing community participation. Our cooperative Fab Lab initiative works with professionals and local communities to innovate the way we design and fabricate sustainable and inclusive public facilities. Upcycling, community, and technology will always keep in mind inside our project, where upcycling pushes us to explore how salvaged wind throw and other solid waste can be repurposed and seamlessly integrated into architectural processes. Community offers knowledge integration and sharing that can prospectively, while also addressing challenges of difficult in work craftsmanship and design complexity. Technology-wise, metaverse automation technologies may assist and advance the cooperative process. To summarize, our objectives are first to test and identify challenges in participatory upcycling and the tension between craft and automation. We use material surveying and prototyping to realize it. Secondly, to propose a human-machine pipeline through the assistance of digital fabrication, which we approach through research through design. And thirdly, to understand how socio-technological tensions emerge in community-led workflows. This is where stakeholder interviews are conducted for us to achieve it. So now I'll pass the time to Jianing to talk more about it.
Our hypothesis pipeline was developed through a 5-step process. First, the material surveying, which includes discovering available waste, evaluating its condition, and storing it in a storage area. Second, material preparation, where we have to dismantle the big pieces and run metal detection in consideration for the CNC milling. Afterwards, we do material detailization through measurement and classification. Thirdly, we conduct user studies and design iterations using AI-assisted designs and AR visualization to facilitate a back-and-forth conversation with community participants. After the initial steps, we will confirm the design and proceed to the next step, which is fabrication. We will rely on technology to carry out part design using available materials through DFMA to utilize the CNC machine as a means for automated fabrication. Lastly, we assemble the pieces through practice and instructions and use heat shrink plastics for joinery. This process also allows participation from the community, and hence we can still have minor adjustment on top. Through material surveying, we can classify the wooden waste into 3 main categories based on their sources, which are discarded furniture, performance waste, and studio wood waste. Discarded furniture is durable rectangular wood that is ideal for CNC milling, but it also has an inconsistent supply, as there was no formal storage, so a lot of wood might have been left outdoors and damaged by weather. Furniture also has much finer detailing, such as metal fittings, which becomes a labor-intensive process. Performance waste is often large wooden sets from Shatin town hall and university drama clubs, with predictable collection schedules. However, they often come in low quality with irregular shapes, and they often have excessive use of nail guns and complicated disassembly designs. The third is studio waste, which has a consistent semesterly supply of wood that is ideal for offcuts on prototyping. However, they are also often small and thin remnants from other projects, so they might be unusable due to CNC blade constraints. Most plastic bottles are ubiquitous and malleable for heat shrink joints. For example, Bonacqua bottles perform the best while some of the test samples deformed. This one is for us to test on the plastic heat joinery. We aim to have no nails and use only upcycled materials. We tested heat shrink on a small scale at first. We also tried to maximize the material usage and make it universal. So whether wood we pick, we can fit into the same geometric formation. It faces thermal threshold and alignment issues. And then we make a full-scale one. We notice that there are constraints on CNC, specifically on curve and thickness deviation. Besides, there are still around 40 to 45% of wasted margins, which we can't recycle. On structural validation, we make load tests, and we settled on around 5 mm tolerance on joints. We received feedback from stakeholders, namely social workers, engineers, and the industry. From social workers, they remark that there might be the challenges in waste management, specifically plastic and electronics. Community-led waste collections are helpful. They prefer the design to be modular, mobile, space-saving, that can be used for community events. On a community level, they remark that it would be exciting to involve the residents in design, inclusive of older adults. However, they do point out that there are safety concerns. Structural engineers have highlighted several key points regarding the use of wooden materials in construction. They emphasize that, rather than just focusing on structural strength, it's crucial to address scalability and robustness. To reduce potential errors, they recommend incorporating safety factors into designs. On industry partners, they remind us there might be issues to be considered on using upcycled wood, such as sugar, moisture, insects, shrinkage, and degradation. They suggest salvaged birch boards or discarded furniture in future practice. They still have concerns about plastic durability and energy used to heat shrink. Structurally, they recommended metal joints. They also encourage standardization to have DFD joinery design to scale in the future. Lastly, they believe that on a community level, upcycling methods will bring long-term benefits when being enabled independently.
At least, we develop a framework of a 5-stage workflow, which is through survey, preparation, design, fabrication, and assembly. We also found out the decision note each stage helps us the technical and social goals, guiding the community participation process. For the future chapter, with the initial design, it gives us much more flexibility in the future designs. We use the Midjourney for AI-generated design iterations and the AI platform for in-suit visualization. And this worked incredibly well at our workshops, and the participants always show the immense joy when seeing our design can be visualized to take photo with. In summary, our key contributions would be to the framework we developed, and deal with the modular design, which adapt to the scale of communities. We learned the importance of the balancing and accuracy with the community involvement, and the digital tools should be support rather than replace the community skills. However, we always identify our resilience on the technicians and the challenges and efficiently scale our structure. Looking forward, we plan to collaborate with the NGOs over the next 6 months, focus on the measure our environmental and social impacts while refining our automation process. Before the end, we would like to show a quick video of the workshop we made eventually. And thanks for listening. We hope to have more and more workshops in the future. Thank you so much.